Hello learners, welcome to Black Slides Online. It's a platform where you come visit and learn for free, entirely for free, at no cost. The only cost is sacrificing your time to learn. Right, so as practical exams are fast approaching, I would like to share with you one of the most frequently asked questions, which is to explain how you can prepare standard solutions. Okay, so we are going to discuss how you can prepare a standard solution. And if, for your information, your chemistry paper 2 requires you to explain how you can prepare a standard solution. Remember, standard solution is simply one whose concentration is known accurately. So this is a solution. A standard solution is a solution whose concentration is known accurately. That's how we define a standard solution. So preparing such a solution takes a series of steps or stages which you must know, and you should be able to outline them when required in an exam. So there's a question here which says, suppose your teacher asks you to prepare a 250 cubic centimeters of 1 mole per cubic decimeter or 1 molar of sodium hydroxide for a chemistry lesson. How would you prepare this solution? Okay, so the question requires you to explain a step-by-step procedure that you do carry out to prepare such a solution. But before we go through the procedure, just a few things about units. Okay. Here we have a cubic centimeter and a cubic decimeter. These are different units. And when you are working with calculations of concentrations, you need to be mindful about having these converted to similar units. Cubic centimeter usually is the same as, 1 cubic centimeter, I must mention this right away. 1 cubic centimeter is the same as 1 milliliter, sorry. Okay, this you must know. And 1 cubic decimeter is the same as 1000 cubic centimeters, which is the same as 1 liter. Okay, so when we talk of 1 cubic decimeter, you should bear in your mind that we're talking about 1000 cubic centimeters, or simply 1 liter of something, of a solution, of a liquid. So when you, let's say you bought a juice from the shop, you bought some juice and it's labeled 1 liter. You as a chemistry student must know that it's referring to this volume, which is 1000 cubic centimeters, or 1 cubic decimeter. Okay, so you need to know these relationships. They are very, very important when it comes to handling concentrations of solutions. Okay, so I thought I should mention this right away before we proceed. Okay, I hope you have taken note of this. All right, so the procedure is a simple one, but you need to pay the best of your attention. How would you prepare a 200 cubic centimeters? Okay, maybe before that, so if we change this to cubic decimeters, you just have to divide by 1000, because I mentioned that 1000 cubic centimeters is the same as 1 cubic decimeter. Okay, that means 250 cubic centimeters is just as good as 250 cubic decimeters divided by 1000 cubic centimeters. Okay, 250 cubic centimeters divided by 1000 cubic centimeters multiplied by 1 cubic decimeter. So this cubic centimeters will disappear, and then this will give you 2 dividing by 1000 is 0.25 cubic decimeters. So in other words, the question is asking you to prepare this volume of solution, but while maintaining the concentration of 1 molar. Okay, all right, so let's go on with the procedure. So first and foremost, you clean you get a clean and dry 1 cubic decimeter standard volumetric flask. Okay, if you don't have one readily available, you have to clean one, or you have to ask those that are in charge of your lab to give you one. Right, so the volumetric flask needs to be dry, one, and also it has to be clean. Okay, so it has to be clean. The reason why it needs to be dry and clean is to ensure that it has no contaminations. It has no contaminations. Okay, because contaminations usually change the nature of the solution. So if your volumetric flask is not clean, make sure that it's cleaned. Okay, so a volumetric flask, in case you've not seen one, is one that is shaped like this. It's shaped like this, and then it should be capable of resting on a bench. It has a mark. It has a mark, and when you when filled with a solution up to the mark, it holds 1 cubic decimeter solution, or 1000 cubic centimeters solution. Okay. And then we are saying that we should, apart from the volumetric flask, you should also have a 25 cubic centimeters beaker. Okay, it's a pretty small beaker, this much. Okay, so it's graduated in cubic centimeters, or in case you don't have one that is graduated in cubic centimeters, you may have one that is in milliliters. So this is 25 cubic centimeters beaker. This is a beaker. And then you said this is a volumetric flask. Volumetric is coming from the word volume because it holds known volumes of solutions. I hope we are sailing in the same boat. In addition to this, you also need a funnel. So a funnel is something that is shaped like this. Yeah, it's used for transferring solutions easily from one container to another. Okay, so that's a funnel. You don't have to worry about graduations. It doesn't need have graduations or markings on it because it's not for measurements. It's just for transferring solutions. Okay, but all in all, we are saying that all these, the beaker, the volumetric flask, and the funnel should be clean. Why? Because we are trying to avoid contaminations. All right, so once again, we are preparing a solution of sodium hydroxide. And you as a chemistry student, you need to know that sodium hydroxide is NaOH. Knowledge of the formula is important because it will help you to determine the relative formula mass, okay, from the periodic table or from any given data. All right, so you need to know the formula because the formula tells you the elements that are found in it. This is sodium, so you have sodium and then oxygen and hydrogen. Okay. All right, so instruction number 2, we are saying, remember that these are the things that you need to write down if you are asked to explain how you can prepare a standard solution whose concentration is known accurately. These are the things that you need to write in an exam. Of course, you didn't say, or you didn't ask this question here to the examiners. No. So you go as far as that point. Okay. Then calculate the mass of sodium hydroxide to be weighed. Okay. There is going to be need for you to weigh the sodium hydroxide pellets. Usually sodium hydroxide is in form of pellets. Which are like basically particles, solid particles of sodium hydroxide. They are called pellets. So you will need to to weigh the right amount using a beam balance but preferably it is important to use the digital balance. So you calculate first, not measure. You have not yet reached the stage when you have to measure. You just do some calculations. You want to know how much sodium hydroxide you will need to weigh to make a 1 molar solution. This should be 1 molar, not 0.1, because that's not what we are preparing. We are preparing 1 molar. Okay. All right. So in order to calculate the amount of sodium hydroxide which you need to weigh on a balance, you will need a formula. This formula here, there is a formula from first principles. Okay, so remember that 1 more, you are taking these numbers from the question. The question says we should prepare 1 molar. Okay, so that's where we're getting these things from. Okay, so what 1 molar means? 1 molar solution is one which is dissolved by taking 1 mole of sodium hydroxide dissolved in 1 liter or 1000 cubic centimeters of water. That's what it means. Okay, so when you take 1 mole of sodium hydroxide and dissolve it in 1000 cubic centimeters of water, you have made a solution of 1 molar. That's what you need to know, the meaning of 1 molar. So you take 1 mole of sodium hydroxide and dissolve it in 1000 cubic centimeters, or just 1 liter, because this is basically 1 liter of water. Okay, so if you do that, it means you have made a 1 molar solution. Okay, but we don't need up to 1 liter. We are told to prepare only 250 mils. Okay, so if 1 molar, if we need to dissolve 1 mole of sodium hydroxide in 1000 cubic centimeters, what about 250 cubic centimeters? How many moles shall it contain? Okay, so just do simple proportion. Okay, so we are saying that in 1000 cubic centimeters we have to dissolve 1 mole of sodium hydroxide. What about 250 cubic centimeters? How many moles? Okay, so we are going to run a simple proportion in which we need the one that is required is put on top. So we have 250 divided by 1000 multiplied by 1 mole. By the way, this is 250 cubic centimeters. Over 1000 cubic centimeters multiplied by 1 mole. We want to find how many moles we shall need in 250 cubic centimeters. So the cubic centimeters are going to cancel out. Okay, and then you divide 250 by 1000. You should be able to get 0.25 moles. Okay, so this is the number of moles of sodium hydroxide which needs to be dissolved, but then, or which needs to be weighed on a scale, on a balance. But then a balance does not measure moles. It measures grams. So we need to change this to grams. Okay, we need to change 0.25 moles of sodium hydroxide to moles. We need to change this to moles. Okay, I mean to grams. Grams. We need to change this to grams. How many grams are these? So once we find the number of grams that are needed, then we go ahead and use the digital balance to measure that mass and then dissolve it. Okay, yeah. All right. So basically that's what we shall need. Okay. All right. So next we needed to. Sorry about this. We needed to write down the formula for sodium hydroxide. Sodium hydroxide, like I said earlier on, is in NaOH, where Na is sodium, then we have oxygen, and then hydrogen here. Okay, so from the formula, it is going to be easy for us to calculate the relative formula mass. Remember, relative formula mass is the total mass of the compound in this case, which is found by adding all the relative atomic masses of the elements found in it. So using your periodic table or any other source of data, sodium has a mass of 23 grams, or a relative atomic mass of 23. But you have to change this to grams. Okay, so sodium alone is 23 grams. Of course, before we move on, oxygen is 16 grams, while hydrogen is 1 gram. 1 gram. 1 gram. Okay, so if you add this up, you should be able to get 40 grams. So that means 1 mole of sodium hydroxide contains 40 grams. So what about 0.5 or 25? How many grams it is going to be? That's what we wanted to do by the end of the day. Okay? All right. So I already pointed out that oxygen will give us 16, hydrogen 1, and you add the 23 for sodium, it will give us a total of 40 grams. Okay, so it means that 1 mole of sodium hydroxide is going to be 40 grams. What about 0.25 grams? So we shall do some simple proportion here. 0.25 divided by 1. Okay, these are moles, by the way. So we have 0.25 moles divided by 1 mole, and then multiply this by 40 grams. We want to find the weight of the sodium hydroxide we need to dissolve. So if you do your calculations properly, you should be able to get 10 grams. So we need 10 grams of sodium hydroxide to dissolve in 250 cubic centimeters of water. And remind you, the water needs to be distilled. Distilled water, pure water. Yeah, so we need to dissolve 10 grams in 250 cubic centimeters of water for us to make 1 molar solution. All right. Okay, so it means that 10 grams of sodium hydroxide pellets, usually these are crystalline, they are white crystals. Put them into 250 cubic centimeters volumetric flask, and then you dissolve using distilled water. Then you make it up, you top up, you add more water up to the mark. Okay. The volumetric flask, like I mentioned earlier, is something like this. Something like this. Yeah. It has a mark right here. This mark is the limit, the extent to which the volumetric flask can be filled with any liquid that is intended. All right. So by that time, you shall have made 250 cubic centimeters when it is fully filled up. Okay. So once dissolved, maybe initially you shall put a little water to dissolve this, to dissolve the pellets. Okay, so once dissolved, then you add more water. You add more water to the flask. You add more water to the flask. Okay, until the water fills up the space or mixes with the dissolved sodium hydroxide up to this mark. You have to be careful when determining the level when this is filled up. Remember, when you taking a reading from a volumetric flask or any other equipment, you have to position your eye to a site which is perpendicular to the mark. So you fill this such that the meniscus, the cavity surface, is aimed at your line of sight, like that. Okay. So when you have made the solution up to that mark, then it means that you have made the desired solution, which is of 1 molar, but also of volume 250 cubic centimeters. I hope we are good on that. Yeah. So you can stop there. By the moment you reach here, that means you have finished answering the question. When we meet again next time, we are going to look at what is called the formula method. The formula method of answering the same question. But for now, I would like us to stop here. Thank you very much. My name once again is Mr. Pochilola. It's my pleasure presenting these video lessons to you, and I look forward to meeting you again in the next lesson. Okay, so if you have not subscribed to the channel already, please consider doing so that every time a lesson is uploaded, you are the first one to be informed. For the time being, bye-bye.